Hey guys, here we are looking at how to chamfer an uneven bore, and this will actually also show you how to chamfer an even bore as well. So first thing you need to do is define this area here. So after you have defined in G54 where the X, Y, Z is of this location right here, then you can move on to what we have here. So, um, so we got the a two flute indexable chamfer tool here, and as you can see, it has a 18 millimeter radius, and inside the control, um, the length of this tool of tool 10, as you can see down here, it says tool 10. Tool 10 has a length of 206.765 millimeters. And um, after you write that down, what that number is, you can take your chamfer tool. Hopefully you have a presetter um, where you can put the tool in the presetter and find out where you want this cut edge to match up on the cut edge here. So the arbitrary number I came up with was um, this point right here. The radius from the center, not the diameter. You have to press radius on the presetter. The radius is 18 millimeters, and so when you drop it down from 206.765 to the point of the cutter where you want this chamfer to be on this edge, then you get the reading of the reading I got is essentially 9 millimeters, 197.765, 206.765. Okay, so now the bore diameter is 50.8, making the radius of the bore 25.4. So how you do this is you write down the bore radius, and you look at the chamfer on the print, and that reads 4.5 millimeter chamfer, and when you add those two numbers, it equals 29.9. So I'm not using cutter comp on here, so you take the radius of the cutter, which is 18 millimeters, and you subtract that off, which gives you 11.9 millimeters. So that's the magic number over here in the program. So now we move over here, and the first thing the program runs is, like I said right here, this G54 is the work offset, where you're defining the the height the height of the part, and this x0 y0. Well, in my example here, x0 y0 is right in the center, and so with that defined, we um, call up the tool length offset of the probe and drop. The probe comes down 200 millimeters above the part, and then with protected, this is a protected move. So if the stylus of the probe hits anything during this move, it will not break. So then after that, it will go into probing mode and probe this. And if it doesn't find anything in the set distance of how much it goes past the Z0, it will go an additional 5 millimeters set by the Q amount. And then it will set the Z in 5223, variable 5223, which is S1. Um, Okay, so that is the center of the pre-bore, and then the probe will protected move to 12 o'clock. It'll probe here and set that in G55. Then it'll move to 9 o'clock, set it in G56. Then it moves to 6 o'clock. We'll set that in G57, a variable number 5283. Notice these are all threes, so 5221 is X, 5222 is Y, and so on and so forth. 5223 is Z. Now, and then the last point that it probes is 3 o'clock, setting it in 5303. Excuse me. So now, after that, after the probing is done, it will calculate. So the pre-bore center is G54. And so all along here is the G54Z subtracting off all of these points, the 12 o'clock, the 9 o'clock, the 6 o'clock, and the 3 o'clock. It subtracts that off, and so however amount the uneven amount is, it sets it on the left here. And then now we drill the hole here real quick. I'm not going to type that out, what those commands are, but down here the critical part what I want to share is okay, the cutter comes down in the center of the bore. It drops down in Z minus 9, feed rate of 2000. And now we see a G3 counterclockwise. So right here, it's here, and it's counterclockwise going into the cut, with right in the middle of there being the center of the arc of 5.95, as you see here. And it goes into the cut. And so you define the x0. The endpoints are the x's and y's. So the endpoint is x0, y 11.9. Now it's into the cut. And it adjusts what that probed point is. So it subtracts off the G54, and the numbers are all set up above. And however amount that probed position is off, the Z will travel up or down. And then it just goes through the quadrants. So now every move it makes, I'm defining the center of the arc with these I's and J's. J minus 11.9. So here it's going from 12 o'clock to 9 o'clock. And the center of the arc is 11.9 millimeters away, which is J minus. And you're telling the control the X and Y moves of where to go. You want it to go X minus 11.9 and Y 0, which is right along here, X minus 11.9. And then you want the Z to travel up and down, however amount this is uneven. So in this particular part, this is uneven because I'm not, obviously I'm not going to be qualifying this surface, or put in another way, I'm not going to be milling this surface, making it all even. So with the probe is setting these locations. So this example here, you can apply this to a lot of different chamfering and any kind of cutting move where you can have it adjust like this. So this works pretty awesome. So, and moving on, this is I 11.9. So here we're over here, 11.9, center of the arc. And we're traveling where? We're traveling to x0, y minus 11.9 as shown here. And with this z fudge also being applied to that move. Moving on to the 3 o'clock cut. So J, where is the center of the arc? J, it's J right here, 11.9. and the x and y. So we're traveling to y0, x 11.9 as defined here with the z fudge, and let's see. Oh, I actually meant that line. And then I minus 11.9. So we're here. Where's the center of the arc? It's right here. And we're cutting to x0, y 11.9 in with the 5243 z fudge. Now notice that that's the same one as before. So but because that is the 12 o'clock position that it was probed, so it will finish out there, and then we ramp off. Now, some of this stuff I did not have to put in here. You don't have to put G3 every time. You put it in one time, and it will stay modal until you change it to a G1 or a G2 or G0 or whatever you want to change it. But just for clarity, I put that in there. And so it ramps off back into X0, Y0. And now the cutting is done. One thing worth mentioning here, let's say this was a milled surface or a flat surface, and you just want it to, well, if you want it to just go into the cut, you don't have to, helically ramp in. You can just, make a linear move, go into the cut, and then if it was all flat, what we would do would be G1 from the center, G1 Y 11.9, okay, going right to the cut edge, and then, oh, okay, and then you would just program G3 if you're going counterclockwise, G3 J minus 11.9. That's it. You don't need to put any XYs. What it's going to, if you type in G3 J minus 11.9, it will just travel around and then come back where it was, because you're not defining where it should stop. So it will just make that move, and then you could ramp off however way you see fit. Well, that about does it. I'm glad you guys tuned in, and hope you enjoyed my video. Hope this helps. Thanks for watching, and have a great day.